How far behind do you think astronomy would be if the Earth didn't have a moon?
This is actually a really thought-provoking question. In that video, Neil deGrasse Tyson explains that having the moon actually slows our rate of progress in astronomy. It's because the moon is bright. If you want to look at something that's faint, it's hard to do if the moon is really bright. But there's a chance that we wouldn't even exist without the moon. And not just humans, I mean life, period. We don't know how life actually started on Earth. There are a number of theories, some much more plausible than others, but we don't know for sure. One of the more plausible theories is that life started in these shallow tide pools. In this theory, organic molecules would pool in these shallow tide pools and interact, and eventually the processes that were necessary for life to happen would have happened in this environment. And this is where the moon comes into play, right? The moon causes the tides on Earth. And keep in mind, the moon is actually moving away from the Earth like a centimeter or two each year. So billions of years ago, the moon was actually much closer. So this tidal effect would have been even stronger, allowing for even more mixing of this nutrients. But even if that isn't how life started, even if life doesn't need tide pools to start, say it started some other way, there's still an argument that we could make that we needed the moon, or rather the event that caused the moon to exist was necessary. The way that we think that the moon formed was a long time ago. There was this young proto-Earth. It was smaller than Earth, not like it is today. And there was this other proto-planet called Theia, which was about Mars size, and there was a collision. This happens in solar systems when they are very young. Collisions like this happen all the time. Planets get ejected out of the solar system. But when these planets collided, they become one. So, Theia is destroyed and the Earth gets bigger, gets much more massive. The heavier elements sink to the bottom, like the iron. That's why we have an iron core. It's heavier than the silicate, the stuff on the outside. And a lot of the debris gets thrown out off the planet into an orbit around the Earth. The planet also gets knocked on its axis. Of course, we know that the Earth has a 23-degree tilt. This is what causes the seasons, you know that. And then that debris coalesces and forms the moon. The additional mass that we got, the heavier elements that we got that went into the core of the Earth, added to the iron, which was completely necessary for the Earth to be able to generate a magnetic field. More massive planet with more heavy elements in the core, like iron, would allow a stronger magnetosphere, which protects us, which protects all life from harmful radiation from the sun. And it doesn't even stop there. That magnetosphere also protects the Earth's atmosphere from being eroded by the star. This is what stars do to the planets that orbit them. They erode their atmospheres away. And with the Earth having a strong magnetic field, it can protect the atmosphere, it can protect the life on it. And we may owe, at least in part, the Earth's magnetic field to this collision, which again led to the moon. The moon does slow the rate of progress that we can make in astronomy today a little bit. We may owe our existence to the moon in several different ways. And astronomy progress would probably be way slower if we didn't exist.